All right, let's try this again. So, review of mostly what will be on your final. Again, you're responsible for anything on test 1, test 2, and what's we did since test 2, including the conic sections. So, study your 2 tests and that review and these problems on this video review. Okay, let's go back to the beginning. I'm going to give you this function, or let's say I give you a polynomial and ask you to factor it. Find all the properties. So the main work's in the factoring using synthetic division, but also don't forget how to do domain, range, x-intercepts, and the graph. So let's talk about the main part, the factoring. I'd probably give you a hint. I would say x equals -1 is a 0. Or maybe I gave you a couple options. So if I gave you a 0, then you're able to do the first factoring step. That is 1, 6. This is synthetic. Bring down the 1. -1 times 1, -1. 6 plus -1, 5. Or multiply those, -5. Add 6. Multiply -6. I put a little bar here. Remainder 0. And it should be remainder 0 if I'm telling you that it's a -1 is a 0. Remember, if -1 is a 0, that means x plus 1 is a factor. When I'm done with this thing, it should be the product of 3 linear factors. Okay, so what do we have here? So we did that part. And now these are my coefficients. That's the x squared term, that's the x term, that's the constant term of the quotient. And then I hope to factor that guy. Right, and that's this cubic. That's how we factor these more complex polynomial functions. Okay, so that's the main part of that one. I don't want this video to be too long, so I won't do every single thing, but I will tell you what else we can do. The y-intercept, the x-intercepts, of course, would be -1, -2, and -3. The domain, the range, the end behavior, this one is one of those guys that has to go like this, and then like this, and then cross at those points. So you could get a decent graph out of it as well. All right, let's keep moving. Difference quotient. So this is something I forgot to do early in the semester, and then we did come back and hit it later. So let's take a look. If I want to do the difference quotient, I need to give you a function. Let's do f of x equals 4 plus x squared. Okay, so before I dive into the difference quotient, I usually find what f of x plus h is. Should be that. And then I figure out what f of x plus h is. I square this out. We did this in class a couple times. That should be x squared plus 2xh plus h squared. All right, so then the difference quotient becomes f of x plus h, 4 plus x squared plus 2xh plus h squared, minus f of x, which is this thing, all over h. Okay, and then usually how these work, they simplify nicely. So let's see if that's the case. If I distribute this through, they both become negative. So that's gone with that. That's gone with that. And it just leaves me with 2xh plus h squared on top. 2xh plus h squared on top over h. Then we can divide h into both of these terms. 2x plus h. And that is the difference quotient. Okay, so let's do some trig. I'll jump around a lot, but that's okay because it's a final. So you got to be familiar with all of it. My note to myself was evaluate some sines and arc sines. So let's just do a couple. Input angle, output the sine of the angle. Cosecant of 2 pi over 3. Let's make that secant. There's a whole bunch of these I could do. I'm just going to do a couple and then leave it up to you to study more. And then we can do some arc sines. And in this case, instead of giving the angle, I give you what the sine is equal to, like negative 1/2. Let's do a cosine. Our cosine of negative root 3 over 2. Okay, start with the basics. So this is unit circle. You're allowed to have your notes. So these could be easy if you have your unit circle there. But I want you to be familiar with them to know them. Sine of 11 pi over 6, reference angle pi over 6. That's a half. But because 11 pi over 6 is in Q4, we know sine's negative there. Secant of 2 pi over 3, what I'm going to do is find the cosine of 2 pi over 3, take the reciprocal. So that means cosine of 2 pi over 3, that's a 6-degree reference angle. That's a half, but it's in quadrant 2. So that's also negative 1/2. And then the secant means flip it upside down. Arc sine of negative 1/2. I got to know my arc sine range. Goes from negative pi over 2 to pi over 2, which means that's where my answer should live. If this is negative, then this is negative. For your sine function, doesn't work with cosine. So I know the sine of pi over 6 is negative 1/2. So this should just be negative pi over 6. Arc cosine of negative root 3 over 2, that should be, what should that be? It should be in quadrant 2, right? And remember, all your outputs for cosine are positive, so these outputs live from 0 to pi. So I'm going to go back in quadrant 2. I know the cosine of 30 degrees is root 3 over 2. So basically it's a 30-degree angle in quadrant 2 positive. If I drew a picture, it would be this guy. That's 150 degrees, or 5 pi over 6. Okay, again, a lot more questions I can ask you there, but I'm just going to give you a glimpse of what you could see. So basically, replace that with any of your 6 arc trig functions: sine, cosine, tangent, cotangent, cosecant, cosecant, and then plug in any of these special values here. Same goes for this. Replace sine or secant with any of your 6 trig functions. Plug in any special angle here. All right, let's do some logs. What's the log base 5 of 25? What's the natural log of e to the 5th? What is the log base 5 of 1 over 125? Okay, so the idea here is find the exponent. 5 to what power gives you 25? Answer 2. Find the exponent. This one, it's given. You can use your inverse properties. This should just be 5. But again, the idea is log base e to what power gives you e to the 5th? It's got to be 5. And this one's a little trickier. 5 to what power gives you 1/25? It should be negative because it's a fraction there, right? And 5 to the 3rd is 1/25, so it should be 5 to the negative 3. Whoops. 5 to the negative 3, making the log negative 3. Okay. Moving along. Identity. Come back to that one. Let's do a graph. I want you to graph y equals negative 3 sine of negative 4x plus pi. Okay, so first put it in standard form. So that's going to be always, step 1 is always to factor out your coefficient of x. So that would be negative 3 sine of negative 4. Factor that out, x. And what happens when I factor a 4 out of pi? It should be pi over 4. And then the plus or minus signs have to agree. So if I factor a negative out of here, it's got to be negative. And now, if this ever happens, it doesn't always happen, but if it does, if that's a negative, we can use the property of sine functions being odd. That means this comes out, to here. With cosine, it would just go away. So basically, these would cancel each other out, and I'm left with okay, and that's in standard form. So from here, I can knock out all the properties. The amplitude's 3. The phase shift is pi over 4 to the right, so positive pi over 4. The period is always 2 pi divided by this number. In this case, it's 4. So period's pi over 2. It goes through one complete cycle every pi over 2. And then the other thing I like to call is the interval length. So the interval length would be the period broken into 4 equal parts. Okay, so that's how I'm going to do my tick marks using that. Always 4 equal parts, because think about your sine curve. It goes 0, max, 0, min. 0, max, 0, min, right? So it's always broken up into this, the cycle or the period's always broken into 4 equal parts, because you're going to have to label the x-axis here. So I'm going to label those pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, pi over 2, and so on. 5 pi over 8, 6 pi over 8, 3 pi over 4, etc. All right, so let's see. We're going to start at pi over 4, so I can graph him. I'm going to do what the sine curve does, but it's going to go up to 3 because that's the amplitude. So this is what I should be looking at forever. Okay, so what else can I give you? You could have if there's a +1 here, it would just move this whole graph up 1. But yeah, that's all the transformations except the vertical. So the vertical would I do last. I just move him up or down depending on what that number is. Okay, I don't want the video to get too long, so call this video part 1. See you in part 2.